I'm Dave. And I'm Rob. And we're here to teach you a bit about the biomechanical principle of impulse. Okay, so impulse is the product of a force being applied, multiplied by the time over which this force is applied. Impulse also has a strong relationship with momentum, as the magnitude of the force and the time over which it is applied determines how the momentum of an object is changed. Now, before we can understand impulse, it is important to know about force. And force, simply put, is a push or a pull exerted by one object on another, and it's controlled by three variables, which are the magnitude of the force, the point of application, and the direction or line of application. Force is measured in newtons. The time over which a force is applied can have a great influence on the momentum of an object, as a force of the same magnitude being applied over a longer or shorter amount of time can have a very different effect. If we're looking at a force over time graph, impulse is the area under the force time curve, and if we were to apply that concept to walking, a person will move forward if there is a greater positive than negative deflection.
So Newton's first law of motion, sometimes referred to as the law of inertia, states that if forces acting upon an object are balanced or in equilibrium, then the acceleration of that object will be 0 meters per second per second. In other words, objects at equilibrium will not accelerate. So check this out. This is a perfect example of an object that is at equilibrium. That ball ain't going nowhere. Okay, but we've spoken about Newton's first law of motion and inertia and force and impulse, but now we have to tie that into Newton's second law of motion. So Newton's second law of motion pertains to the behavior of objects for which all existing forces are not balanced. According to Newton, an object will only accelerate if there is a net or unbalanced force acting upon it. The presence of an unbalanced force will accelerate an object, changing its speed, its direction, or both its speed and direction.
If we use a tennis ball and racket as an example, a ball comes towards a player. It has its own momentum. As the player hits the ball, he changes the momentum of the ball in the other direction. The impulse is the stimulus for the change in direction, with the player's racket applying a force and the time that the racket is in contact with the ball being the time over which the force is applied.
So, if we use our ball again, Newton's first law shows a perfectly still object in equilibrium with no acceleration. However, my finger produces an impulse which causes the ball to accelerate and move. So there you have it, impulse explained by Dave and Rob.